In this problem, we have a spring that is hung vertically with a 0.75 kilogram mass attached. So we get a 0.75 kilogram mass down here, which causes the spring to stretch 0.3 meters. So it would be originally with no mass on it at x equals 0, and then it gets pulled down to an additional 0.3 meters due to the mass attached. The mass is then pulled down several centimeters, so we're going to pull it down, and it's released, so it starts oscillating up and down, and we want to know what the period of that oscillation is. Now, if we go to our list of equations, we know the period is equal to 2 pi times the square root of mass over the spring constant. And we're given in the mass of the problem that's the 0.75 kilograms, and we're trying to find the period, but we need to figure out what the spring constant is in order to plug in. So in order to determine what the spring constant is, we're going to take advantage of the fact that we know how far it stretches due to the weight of the mass itself. We can say the force of the spring minus the force of gravity equals mass times acceleration in the y direction. Acceleration is 0 because this is before we pull it down and let it oscillate. So this is when it's just pulled down the 0.3 meters due to its own weight. So we can say that the spring constant times the distance the spring is stretched is equal to mass times our gravitational field strength. So I plugged in the 0.3 meters for x, the 0.75 kilograms for mass, and the 9.8 meters per second squared for the gravitational field strength. That gives me a spring constant of 24.5 newtons per meter, which then I can plug in and say our period is equal to 2 pi times the square root of 0.75 kilograms divided by the 24.5 newtons per meter. And that gives us a period of 1.1 seconds.